Welcome back. In this video, we are going to explore one of the most famous formulas in geometry. The area of a circle is pi r squared. But instead of just memorizing it, we want to understand why it makes sense. Let's start with a circle. Now, imagine cutting this circle into 8 equal pieces like I have here. The pieces are like thin slices of the circle. Next, we want to rearrange those pieces by alternating them up and down so that our shape begins to look like a bumpy parallelogram. Like this here. It's not a perfect parallelogram yet, but it's starting to resemble one. Let's think about the dimensions of this new shape. What is the slant height, or the height-like measure of this rearranged figure, the length of this side here? Well, that's the radius of the circle. That's the distance from the center to the outside of the circle. It's one of these edges here that I have marked in red. Each slice stretches from the center to the edge, so the height of the rearranged shape is about r. Now, what about the base? When we alternate the slices, half of the circle's curved edge is along the base. But only half. The other half is on the top. That means the total length along one side is about half the circumference. So, since our circumference is 2 pi r, half of that is pi r.
Yes.
So, this rearranged figure has an area of approximately base times height, or pi r squared. That gives the formula for the area of a circle. Now, let's ask, what happens if we cut the circle into more pieces? What if we cut it into 16 or 32 or even more, like 100? The bumps get smaller and smaller. The rearranged figure starts to look more and more like a rectangle. That makes this argument even stronger. Eventually, we can think of the area as coming from a rectangle with a base of pi times the radius and a height of the radius. So the area is in fact pi r squared. This is such a nice visual argument because it connects a new formula to an area idea students already know. Instead of treating the circle as mysterious, we can transform it into a shape that's easier to reason about. As future teachers, this is a great opportunity to emphasize that formulas can come from structure and rearrangement. A common student misunderstanding is to wonder where the pi comes from or why the radius is squared. This model helps us answer both questions. The pi comes from using half the circumference, which is pi r. The r squared comes from multiplying that base, pi r, by the height of r. So both parts of the formula have a geometric meaning. Excellent work. You are doing exactly the kind of mathematical reasoning that helps formulas become meaningful instead of arbitrary.